resistors. So what is parallel combination? It's very simple. Three bulbs are connected directly to the electrical source. If you replace this battery and you take three negative terminals to the negative terminal of the your plug socket, and positive all three together to the plug socket, so all of them will receive the same voltage. In a house there is 220 volt, so if you push in two different bulbs in the same socket, so both the bulbs will receive the same voltage. Alright, so that's very important. You have to understand that. And so here all of them will receive same voltage, 6 volts. Suppose this battery is of 6 volt, they will receive. So I've made the symbolic diagram over here. So now what is happening, have a look. This is here, the symbolic diagram is here. So what is happening, the current is coming and it gets distributed differently according to the different resistance. Your common sense will be lower resistance means it invites higher current. So if suppose there are two wires, two resistors, one has got 6 ohm resistance and another one has got 3 ohms resistance, then the 3 ohms will invite more current and 6 ohm will invite lesser current. It's like, resistance means like a traffic jam. You've got two options. One has got more vehicles and another lane has got less vehicles. Two roads you have got. So obviously try to go, most of the people will start going to the lesser jammed road. Its current flow is also like that. Current picks up a path of less resistance and therefore the current gets distributed. So that is one of the parts. So here we understand. Now I have written in parallel combination, the current gets distributed but the voltage remains the same. The current gets distributed but the voltage remains the same. If one of the resistor is switched off, then rest of the resistors will work. Mind that. So now I try to see if I can give you the equivalent resistance. That means if I replace all these three resistors and if I have to place in a single resistor equivalent to the effective resistance of all these three, then what will happen? We know by Ohm's law I is equal to V by R. So since the voltage is same for the R1, voltage is same for the R2 and voltage is same for the R3, and if it was more and so on, they all receive the same voltage, that is the exact voltage being supplied, it doesn't diminish. So V by R is equal to, we take V common, 1 by R1 plus 1 by R2 plus 1 by R3. So this goes, so the VV is cancelled, so 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. See, your understanding should be good. Sometimes they check your language also in physics. So what you have to say, what is the statement to be given for equivalent resistance in parallel combination? So if you tell in parallel combination, the reciprocal of the equivalent resistance, is equal to the sum of the reciprocals of individual resistors, right? So you can rewind and write that definition, right? And in series combination, what happens? In series combination, the equivalent resistance is sum of the individual resistors. So that's the difference. Now suppose I've got to work on this. I need some board space, so I rub this off, right? I'm going to rub this off and then let's have a look over here. So we got 1 by R is equal to 1 by 2 plus 1 by 2 plus 1 by 3. So, right, 1 by R is equal to the 6 over here, 2 3s are, 2 3s are and 3 2s are. So 1 by R is equal to 3 3 6 to 8 by 6. So R is equal to 6 by 8, that is 3 by 4, that is equal to 0.75 ohm. So the first sum gives you one important message. The equivalent resistance in a parallel combination, if it's a pure parallel combination, then it is lesser than the smallest of its magnitude is lesser than the smallest. 2 is the smallest and we are getting 0.75. So that means, suppose you've given a 4 ohm resistor and a 2 ohm resistor, and they say that how you will get equivalent resistance lesser than 2, then your obvious answer will be we will have to do the parallel combination, right? So that's one part. In another part, if you get to work on two resistors in parallel, then we can use maths and we can derive a formula like this. You can make 1 by 6 plus 1 by 3, or let us derive a formula for 2 1 so that we can work it out. 1 by r is equal to, it will be r1 into r2, r1 plus r2. So that goes r is equal to r1 into r2 by r1 plus r2. So now this is it, you can work out fast. In parallel combination of two resistors, the equivalent resistance is product by sum. So that's 18 by 9, that is 2 ohms. For this you can be fast. Alright, so equivalent resistance is 2 ohms over here. Alright, and how much is the total current flowing? If you have to ask, we have to ask, so I is equal to V by R. Suppose I ask over here, then you find out the equivalent resistance, and then you use 18 by 2, that is 9 amperes. You can go another way, a smarter way also. If you are observing, a smarter way can be, have a look, a smarter way can be, let's see, let's just check on what will happen. I try to find out I6, that means current across the 6 ohm resistors. So I know it is receiving 18 volt and the resistance is 6, so it's receiving 3 amperes. And here I3 is equal to now how much is the total voltage? 18. It's also receiving 18 and then 3, so that is 6 ampere. If you add it, you get a total of 9 amperes. Is the same answer. And also again, this method gives you another message that less resistance, higher current, higher resistance, less current. That's all.